Okay, so this is example 4.5 from your textbook, and the problem asks you to find the tension in each one of these cables. Okay, now I've gone ahead and typed in this angle is going to be 50 degrees, okay, right here, and this one's going to be 25. Now we got that by doing 90 minus 65 gives us the 25 degrees, and 90 minus 40 gives us the 50 degrees. All right. The other thing is that says that's a 200 kilogram mass. Okay, so we need to convert that to a force. So weight is equal to M times G, which is equal to 200 kilograms times 9.8 meters per second per second. So the weight is going to be equal to 1,960 newtons. Okay, so now that we have that, let's go ahead and write our equations of equilibrium. Alright, so if we write sum of the forces x, those are equal to 0 because we're at equilibrium. Alright, and we're just going to call the forces A and B. Alright, sorry, A up there and C here. Okay, so A and C both have an x component. Cx is positive, and AX is in a negative x direction. Right? So when we write that more specifically, we get C cosine of 25 minus A cosine 50. Alright, so here the deal is we basically have one equation and two unknowns. So let's solve for C, and we can say C times cosine 25 is equal to A times cosine 50. And so dividing both sides by cosine 25, we get C is equal to A times cosine of 50 divided by cosine of 25. Okay, I'm going to pause for just 1 second to crunch that in my calculator. Alright, so I'm left with C is equal to 0.7092. Well, there we go, 7092 A. Alright, so now let's write sum of the forces Y. That's also equal to 0 because we're at equilibrium. Okay, and there are 3 Y components. Alright, A and C are both positive. They're pulling up, right? Sorry, I should have drawn these in for you. Earlier. Okay. So both of them are pulling up and the mass is pulling down. So we have CY plus AY minus 1960. Okay. So let's then write that out more specifically. C sine of 25 degrees plus A sine of 50 degrees minus 1960. Okay. So now we have our equation for the sum of forces Y and the sum of forces X. So let's do some plugging in here. we're going to plug in for C. Okay, so we have 0 equals 0.7092 C times the sine of 25 degrees. Plus A sine 50 minus 1960. Okay, so I'm going to go ahead and move the 1960 to the other side. 1960 newtons is equal to, let's do a little plugging in. So I get point, that's supposed to be A right there. Okay. Alright, so that's 0.2997 plus A, that is, plus 0.7660 A so this is 1.066, oops, so that is 1960 newtons is equal to 1.066 A. So we get A is equal to 1839 newtons. Okay, now if we plug back into the equation above to get C, we get C is equal to 1304 newtons. I just took this value for A, plugged it right in there, and got 1304 newtons. Okay, so that's the solution to that problem.